Hello students, in this video you will find properties of base. I am going to tell you properties of base in two parts. First, physical properties of base. Physical properties of base. Now, first I will tell you about physical state in which they are found. A large number of many bases are found in amorphous form. They are amorphous solid and some are crystalline solid. Number two, taste. They have sharp and bitter taste. Bitter taste, you know, sharp, bitter taste, not sour, sharp and bitter, sharp and bitter taste. Then that also remember, sharp and bitter taste. Number three, their feeling. Soapy and slippery to touch. Whenever you are touching with hand, like you will feel like soap or slippery. Why is it so? If alkali like NaOH, KOH or alkali is coming in contact with the skin, it reacts with oil present in the skin in the form of fat to form soap, and soap is slippery. Then here, if question comes, why is it slippery, soapy to touch? This is the reason, because base or alkali react with oil to form soap. When if it comes in contact with the skin, it reacts with oil present in the skin in the form of fat to form soap, and that is why it becomes slippery. Now here, number four, indicators effect. Indicators effect. Now what is this indicators effect? First, litmus. Second one, methyl orange. Methyl orange. Third one, phenolphthalein. Phenolphthalein. This here litmus, base turns red litmus blue. Red litmus turns blue. And here methyl orange turns from orange to yellow. This is a weak organic base. Methyl orange, weak organic base, in basic medium turns yellow. Phenolphthalein, weak organic acid. This is weak organic acid. It changes from colorless to pink. In basic medium, it turns pink. This is about indicators effect. Now next is here. You can say conductivity of the solution. Conductivity of the solution. Aqueous solution of sodium hydroxide, potassium hydroxide is a strong electrolyte. It allows large amount of current to pass through it. But aqueous solution of weak base like lime water, ammonium hydroxide, that allows small amount of current to pass through it. These are weak electrolyte. Now let us see chemical property of base. Chemical property of base. First, in chemical properties, first I am going to tell reaction with carbon dioxide. Carbon dioxide is acidic. Base react with CO2 to form corresponding carbonate salt and water. See the reaction. One reaction here, like NaOH plus CO2 forms Na2CO3 plus H2O, like that. Next is like that KOH react with CO2 to form K2CO3 plus H2O. Now you can check it is already balanced. 4 oxygen, 4. Now one more, lime water. What is called this? Lime water. When CO2 gas is passed through lime water turns milky. Lime water turns milky plus H2O. If large amount of gas is passed, CaCO3, this product is there, you are passing CO2 for long time, then there is formation of colorless solution. That precipitate will dissolve to form colorless solution and milkiness disappears. And if it is heated, CaHCO3 whole 2 is heated, then again milkiness appears. It undergoes decomposition and milkiness appears, again solution become milky. Most important, this one for practical class also, it is used for testing CO2 gas. Like that, any other reactions also you can write. Number 2, reaction with their acid. Base react with acid to form corresponding salt and water. This reaction is called neutralization reaction. Neutralization reaction, like one example, NaOH react with hydrochloric acid to form salt NaCl plus H2O. Calcium hydroxide react with acid to form salt and water, like that. Here insoluble base, cupric oxide, this is a black solid, very important, black solid, react with acid like H2SO4 to form copper sulfate, blue solution of copper sulfate, and plus H2O. Like that, base react with acid to form corresponding salt and water, CuSO4 plus H2O. Now next is number 3. Reaction with metal salt solution. Metal salt solution. Heavier metal salt like copper, zinc, lead, aluminium, heavier metal salt solution react with alkali or base to form insoluble respective metal hydroxide. Because of difference in their solubility and color, this reaction is used in qualitative analysis for identification of cations. For example, suppose copper sulfate is treated with ammonium hydroxide base. There is formation of copper hydroxide blue precipitate plus here 2OH, 2NH4OH, NH4 twice SO4, NH4 whole 2 SO4, like that. If excess NH4OH is added, then CuOH whole 2 plus NH4 twice SO4 plus excess NH4OH. Then there is formation of deep blue solution Cu tetraamine copper copper 2 sulfate plus water. You can balance the equation. 4 oxygen, 2 and 2, 4, equation is balanced. This is a deep blue solution. And one more example, see, suppose you are passing there to ferric chloride solution, green solution, NaOH. React with this to form dirty green precipitate of ferrous hydroxide plus NaCl. You can balance the equation. Dirty green precipitate of ferrous hydroxide, FeCl3, NaOH is added, solution, formation of reddish brown precipitate and NaCl. Precipitate does not dissolve on adding excess NaOH. Only once there is formed reddish brown precipitate, and precipitate does not dissolve. Number 4, reaction with ammonium salt. Solution, ammonium salts. All ammonium salt give ammonia gas on heating with alkali or base, remember. And one example, NH4Cl when heated with sodium hydroxide, just warmed, there is formation of sodium chloride H2O plus NH3. This ammonia gas turns red litmus blue. It also turns Nessler's reagent brown. Then next one more example, ammonium sulfate react with KOH to form salt K2SO4, 2 potassium right here 2 plus NH3 plus H2O, right, plus H2O plus NH3. This NH3 gas is same thing, pungent smelling gas, and it turns red litmus blue. You will remember that K2SO4 plus NH3, 2NH3 plus 2H2O. Like that, ammonium chloride, ammonium sulfate, ammonium phosphate, ammonium dichromate, any on warming with alkali give respective salt and a pungent smelling ammonia gas which turns red litmus blue. That's all for today. Again, next class, next video, you will find very interesting thing, next topic of this chapter. Thank you.